Hi, lovely viewers, once again. This is Kwakudro's channel. This is where science becomes life. This is where science becomes easy. This is where science is applied to real life experience. This is where we explain science to the very bottomless level for everybody. Now, today we have a simple machine, and this type of simple machine is known as a lever. And what is a lever? A lever is just a rigid bar that has a pivoted, that has load, and that has effort. Now, today we are going to explain some terminologies that is applied in lever. And what are the terminologies? One, we have what we call the work output. Every simple machine has work output. Now, what is the work output? Now, over here, I have my load over here. You can see the load over here. So, when you multiply the load and you measure the distance from the load to the pivot, it gives you the work output. So, the work output is a product of the load and the load distance, that is from the pivot to the load. Now, we also have what we call the work input. Now, what is the work input? It is the effort applied over here and the distance between the effort to the pivot, which we call effort distance. So, when you multiply the effort distance and the effort, you get the work input. If you want to find the efficiency of a machine, it is the work output divided by the work input expressed as percentage. So, today we have explained the efficiency of a machine. Very simple. Shall we go to the board and see the calculation or the breakdown? Okay, now another way that you can also find the efficiency of a machine is by concentrating on what we call mechanical advantage. Now, what is mechanical advantage? Is the ratio of the load to the effort applied. So whenever you divide the effort by the load, you get what we call mechanical advantage. So mechanical advantage is the ratio of the load to the effort applied. You can use that one. Then you can also use what we call velocity ratio. And what is the velocity ratio? Velocity ratio is the effort distance. So the distance between the effort divided by the distance between the load. So if you know the effort distance and you divide it by the load distance, you can get velocity ratio. So knowing that, you can divide mechanical advantage divided by velocity ratio multiplied by 100, and you can still get efficiency of a machine. So let's go to the board and find the deduction and calculation. Let's do it. Hello once again. Now let's welcome back on the deduction from the board. Now, as I said, when we talk of the work output, you multiply the load and the load distance to get the work output. And if you want to get the work input, you multiply the effort applied multiplied by the effort distance. So when you divide the work output to the work input and you express it as percentage, it gives you the efficiency of a machine. Now, the unit is in percentage. So let us also see the other method that I explained. Right, now in the second method, we use mechanical advantage. And we say mechanical advantage is the ratio of the load to the effort. That gives you the mechanical advantage. Then we also have the velocity ratio, which is the distance moved by the effort divided by the distance moved by the load. And you can use the mechanical advantage divided by the velocity ratio times 100, and you can still get the efficiency of a machine. It is either you are using the work output and the work input expressed as percentage, or you are using mechanical advantage over velocity ratio multiplied by 100. Please, today is the first day that you are watching me. Please subscribe to my channel and please press the notification bell, and so that more video of this surfaces, you'll be the one to know. Have a nice weekend and take care. Bye.